And so this last video for this unit, we're going to talk about determining sample size for a quantitative variable. So just at the end of the last example we did, we talked about how sample size can play a role in how wide our interval is. Remember we talked about the bigger the sample size, the narrower our interval actually was. And so the width of our interval was important because a narrower interval is more informative. So then maybe a question is, why don't we always just then take a really large sample? Well, I mean, of course, sometimes getting data is easier in some cases than in others. We don't want to take way too big of a sample size, but it costs a lot of money and possibly takes a lot of time. So we're going to talk about what we need to know in order to estimate sample size. So here are the things that we're going to need to know. So I need to know how confident you want to be. Do you want to be 90% confident, or do you want to be like 95% confident? So I need to know that. I also need to know how far off you're willing to be. Or how close to you, I guess you could say, do you need to be. Which is basically telling me I need to know about what your margin of error is. Are you willing to be off $10, or are you okay with being off $20? So how far off are you willing to be? The final thing it says that we actually have to know what sigma is. And that's probably our problem here. Remember, one of the biggest things we talked about inside this set of notes is that we need to know what sigma is. So I look at my actual formula would look like my sample size would need to be at least as big as z, which is based upon my confidence level, times my standard deviation, which is probably the one that makes us feel most uncomfortable right now, divided by our margin of error, all squared. So some notes about this. We must have an idea for sigma. This can either be a ballpark number, or it could be maybe a sample standard deviation that we're using. Like maybe we took a small sample and we at least have an idea of what that must be. The other sort of weird part inside of here is, remember, up to this point in this set of notes we've been using a t instead of a z. Well, why can I not use a t here? Let's look at our chart. Remember, there's two different things I needed to know here. I need to know how confident you want to be, which I'm also saying I need to know right now. But then I also need to know degrees of freedom. In order to find degrees of freedom, I need to know your sample size. That's a problem because that's what I'm trying to find. Right? So I can't really use a t in this place. So the good news, if my sample size turns out to be at least, let's say, 60, the z versus t isn't really a worry. If your sample size turns out to be a little bit smaller than that, or I mean a lot smaller, then you're going to be worried that we need to start being concerned if our sample sizes are smaller than 60. That's what we're seeing a lot of times. We have much bigger sample sizes than that. And so for the most part, we haven't had too many issues with needing to do that replacement. And of course, our last thing we're going to do here is practice this through a couple of different examples. So suppose Pizza Hut wants to estimate the mean number of pizzas it sells each day. In fact, maybe they don't want to throw away too much dough or run out type idea either. So they believe this varies with a standard deviation of 65 pizzas. Alright, so now how did they get that number? Hopefully based upon some actual data they had collected. They want to figure out how many days they should be sampling to be sure within 16 pizzas. That's how far off they're willing to be, is no more than 16. With 99% confidence. Now for the 99%, this is a little reminder. I mean, you may have these memorized, but this is a quick little reminder. So now we're finding z. Z was centered at 0. We put how confident we are in the middle, so that 99% goes in the middle, which gives us 1% left over, so half of that is going to go on either side here, so 0.005 on either side. Our goal, of course, is to find that number. So I'm going to go to the table, looking for everything to the left of that, which is 0.995. And so if I pull up my table here, I'm going to find my 0.995, or the closest thing I can to it. And here's a number pretty close. If I look, that gives me a z of 2.58. That's kind of one little reminder of how to find z. So once I have it, I have all of my numbers then to plug into my formula. My z is 2.58. My standard deviation is 65. My margin error is 16. And this gives me 109.86. Remember, we can't sample only part of a day, so I'm going to round this up to 110 days. Alright, with our last example here, Old Navy wants to estimate the amount of sales they have in a week. So I believe that this varies with a standard deviation of $4,500. So we'll figure out how many weeks they should sample to be within $1,000. With this time 95% confidence. Going through the same picture here, 95% in the middle, 5% left over, split up into two is 2.5% on either side. We go to the table looking for everything to the left, which is that 0.95 plus the 0.025, so this one I'm looking for 0.975. And this one I do actually find perfectly. So my z is 1.96 for this one. So then we're going to plug those numbers into my formula. N is going to need to be at least as big as 1.96 times our $4,500. Margin error of 1,000 gives me 77.79. Rounding that up to 78 weeks. Now, of course, we just do the calculation. How they can use that is, okay, can I get that big of a sample, right? So they decide, can I actually do that once I figured out how big of a sample that I need? Of course, I can't take that big of a sample if it's too big. I've got to be able to compromise on a couple of things. So what will I have to be willing to do? Lower my confidence? Maybe one way. That will make me not have to sample as many. I could also increase how far off I'm willing to be. So maybe before I wanted to be within 16 pizzas, maybe if I say, well, I only want to be within 20 pizzas, that will change how big of a sample that I need to take. Alright, so that kind of concludes looking at inference for a mean. So you have a hypothesis test, a confidence interval, and how to find sample size. And all of those things, of course, are on your formula sheet. Our confidence interval, our hypothesis test, and that sample size formula we just looked at.